Hi folks, Dr. P here. This is practice problem number 9 from the probability assignment. Use the following information to determine whether the events A and B are mutually exclusive. Okay, so in all of these examples here we have two events. We have event A. So for example in A here we have event A, we have event B. Okay, and it's the same thing in all of these. Here is actually the complement to B. Okay. Now, in order to determine if these are mutually exclusive events, we're going to be taking advantage of the formulas for mutually exclusive events. So the probability, so let's just write those down. So the probability of mutually exclusive events, are given by the following relationship. So probability of A or B occurring. So this set notation here, this is union, so A or B equals the probability of event A occurring plus the probability of event B occurring. So for mutually exclusive events, that's it. You could visualize this as a Venn diagram if you want to. You have event A here. You have event B here. Your universal set will be over here. And two events are mutually exclusive if there is no overlap. Okay, so either A can occur or B. Okay, but both cannot occur. So that's the probability of mutually exclusive events. Probability of non-mutually exclusive events. The formula for that is very similar. So it's going to be the probability of A or B equals to the probability of event A occurring plus the probability of event B occurring minus the probability of A and B occurring. This symbol here, again from set notation, means the intersect. So what we're doing here is for mutually non-exclusive events, we have to subtract the overlap. So we can visualize this again as a Venn diagram. So here is our event A. Here's our event B. And now there is an overlap. So if you remember from set theory, to avoid double counting, when we want to determine the probability of A or B, to avoid double counting this region that's represented by the overlap, we have to subtract that overlap. Okay, so we can take advantage of those two formulas to determine whether these events A and B are mutually exclusive or not. Okay, in A here we have the probability of event A occurring being a half, probability of event B occurring 1/5, and the probability of A and B occurring equal to 0. So here's the key. So the probability of A and B occurring equals to 0. That means there is no overlap. So if we look at this formula over here, this term here equals to 0, which means we're actually left with this formula here. The probability of mutually exclusive events. So this would be a mutually exclusive event. Mutually exclusive event. In B, here we have the probability of A occurring 0.3. The complement to A, the probability of the complement to B occurring is 0.8. Now we cannot use the complement to B. We need to have the probability of B. So the probability of B is simply going to be 1 minus the complement of B. So if we plug in our number here. So instead of, so it's going to be 1 minus 0.8. So that means that the probability of B occurring is 0.2. Okay, so now what we're going to do, we're going to use this formula here. We're going to plug in what we have. We have the probability of, well, actually we're going to use this formula here, sorry, because we have the probability of A or B occurring. It's 0.4, so it's going to be 0.4. And then we know the probability of A occurring and probability of B occurring. It's just 0.3 and 0.8. 0.3 plus 0.8. So the left-hand side is 0.4. The right-hand side is 0.11. And what this shows us is that the left and the right-hand side are not equal. Okay, the right-hand side is actually what's missing here is the subtraction of that intersection, the overlap. So this means that these are not mutually exclusive. So this means that, so basically left-hand side is not equal to right-hand side, which means that these are not mutually exclusive events. And then in C, here we have the probability of A, we have the probability of B, we have the probability of A or B. We can also write this as probability of A or B. This is union, is 13 over 2. 13 over 20, sorry. So here we just can plug this into, again, it's going to be this formula up here. Right? So the probability of A or B is 13 over 20 equals the probability of A, which is 2 over 5, plus the probability of B, which is 1/4. And then because we're adding two quotients here, two fractions, we need to make sure we have a common denominator on the right-hand side. Left-hand side stays the same. So the common denominator here will be 20, which means we're going to get 8 plus 5 in the numerator. So left-hand side is still the same. Right-hand side, 8 plus 5 is 13. So the left-hand side equals the right-hand side this time. And that means that we're dealing with mutually exclusive events. I hope that helps. Until next time, may the math be with you.